Okay, you can notice that from the title, adding rational numbers. Now, I've separated adding and subtracting rational numbers out because these are the ones that we go a little bit slower through. The adding and subtracting, you have your rules you have to follow, and when we get to subtracting, how you change it into an addition again. And so I like to break these ones down. So let's start off with adding some fractions. So in the first one, let's look at a negative 7 over 2, and we're just going to add that to 5 over 4. Okay, so we don't have any mixed numbers in there, so we don't have to worry about that. But on both the examples, I'm going to show you ones with different denominators, because when you're adding and subtracting, you have to have the same denominator before you can add or subtract the top. So here we're looking at it, and I'll bring the hand back down. As denominators, we've got a 2 over here, and we've got a 4 over here. So before we can do anything else, we need to have the same denominator. So I'm going to look at that, and a number that is common, the greatest common factor of both of those in this case, that they'll go into is 4. So I'm going to use 4 as my denominator for both those fractions. Now the 5 over 4 didn't change, so that's easy. We just leave that as 5 over 4. But the 2 over 4 did, and let me go to a different color. So we're taking this fraction and we're changing it to this fraction over here. So to do that, we had to multiply that by 2, say, to get the 4. So if you do it to the bottom, you have to do it to the top to find this numerator. So we're going to multiply, we'll put it over here, that one by 2 also. Okay, so negative 7 times 2 gives you negative 14. So now we have a 4 on the bottom, so we can go ahead and subtract the numerators now. So when we do that, if we look up here, we have, we'll go back to the hand, we have a negative 14, and then we have a positive 5. And even though this is an addition problem, because that's negative and that's positive, they're opposites, so we have to subtract them. So if we subtract those, we get, go back to my pen again, we get a 9. Okay, and we keep the same denominator, so it's 9 over 4. Now you've got to go back and decide, is that going to be positive or negative? And we look just at the numbers, not the signs, remember. And if we look at 5 over here, and then we go over to the other one, we have a negative 14, or 14, that's all we're looking at right now. And that's bigger, so it's got a sign of negative on it, so we keep that as a negative fraction. So like with anything, we've got a improper fraction here, and so we're going to reduce that down to a mixed number, and we see how many times 4 will go into 9 without going over. In this case, it happens to be 2 times, so that's where we get our whole number from. And 4 times 2 is 8, so that leaves 1 left over, so 1, and remember, keep the same denominator, which is 4. So 2 and 1/4, and we have to remember that that's still negative. Okay, so that's the first kind, and I forgot to put a letter to that one, so we'll call that one A. Okay, let's look at another example, and I'm only going to give you 2 examples with adding rational numbers, because that's pretty much going to encompass everything that I need you to know for this test. So let's do a negative 3 1/2, so we have a mixed number in there now, and we're going to add that to 2/3. Okay, so on this one, before we do anything else, we want to change that. So the negative 3 1/2, we want to put that as a improper fraction, so we're going to just rewrite everything. I'm going to do it down below this time. So I'm going to take that 3 1/2, I'm going to take the denominator times the whole number, so 2 times 3, which is 6, add the 1, which is 7. So we go 7 over 2, and that whole thing was still negative. And then plus, and we didn't do anything with the 2/3, so 2 over 3. Okay, so now when we look at it, we still can't add yet because the denominators. So we still have 2 as a denominator on that one, and we have 3 as a denominator on the second fraction. So we have to find common denominators. So I'm going to rewrite the fractions because we are going to change both of those fractions when we rewrite them. And I'm going to do the easy way. I'm just going to multiply them together and get 6. Okay. So now we've got to change the numerators on both those fractions. So let me go to light blue to show you the steps here. to get this one over here, we had to multiply that by 3. So I multiply the top by 3 also. So 7 times 3 will give us 21. And that's a negative 21. Okay, so that's changing the 7 over 2, negative 7 over 2, and the equivalent fraction is negative 21 over 6. So now we're going to change to 2/3 over here. So to get the 3 to be a 6, we multiply that by 2, and we're going to do that same thing to the top. So multiply that one by 2, so 2 times 2 is 4. So now we've cleaned up our fractions. They've got the same denominators, and now we can go ahead and add the numerators. So I'll go ahead and put in the denominator first because we know that's 6. Now again, we have a negative 21 and a positive 4, so they are opposites as far as the signs go, so we have to subtract them. So that's going to give us a, 17. Okay, and we look at the numbers, not the signs. We have a 4 over here and a 21 over here. The 21 is bigger, so we keep it signed, so that is a negative. So we've got a negative 17 over 6. Again, improper fraction, so we'll reduce that down to a mixed number. 6 will go into 17 twice, and 6 times 2 gets you 12, so 12, we have 5 left over to get up to 17 again. And then our denominator over here is still 6, so we put that over here, and that whole thing is negative, remember? So now we're down to negative 2 and 5/6. So those are the two examples you'll see. Remember, the most important thing when you're adding and subtracting, which we'll do next, you need to have the same denominator before you can go ahead and add the numerators. Okay, you have a couple problems like this, and we'll see you right back.